Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Problem 5.2. The statement of problem is shown in the figure. You are required to find the bending moment and shear force diagram and also find the equation of shear force and bending moment curves. So let's start with this problem as well. So as you know that the beam is given over here, so you have to draw the free body diagram of the beam. So let's say this is the beam, so you have to and this there is a concentrated load that is given at this point B. So this is, let's say for example, this is at point B. So this force is given as P and this is point B. There is a force, reaction force, which we have to determine, that is RA, and at point C there is a force, reaction force, that is represented by RC. So these are unknown forces and we have to find this force. The distance of the point P or concentrated load from point A is given as A, while this distance is given as B, and total length of the beam is given as L. So first we will find the RA, the value of RA and RC. So for that I first take the moment at point C is equal to 0 for finding the reaction force at RA. So moment about C is equal to 0, assuming the counterclockwise rotation is taken as positive. So if you are taking the moment about this point is equal to 0, so one force is the RA force, which is acting upward. So RA and the perpendicular distance is L, and this creates a clockwise rotation, so that's why it will be negative. The second force is P, which is acting downward. So this force and this perpendicular distance is B, this distance B. So it will create, as it create a counterclockwise rotation, so that will, this will moment will be positive and this will be equal to 0. So implies your reaction force at point A comes out to be PB over L. Now the beam is not symmetrical and you have to find the reaction force at C. So this is equation 1. Now for finding the reaction force at RC, you have to take the moment about point A is equal to 0. So sum of all the moment about point A is equal to 0, taking the counterclockwise direction as positive. So one force that will tend to create a clockwise rotation is P into perpendicular distance A, and it will be negative because it is going to rotate it in clockwise direction. The second moment is due to RC, reaction force, and the perpendicular distance between RC and R at point A is L. So RC reaction force at point C into perpendicular distance L, that will create a moment, but it is counterclockwise, so that will be positive. So RC will be equal to PA over L. PA over L. So this is the reaction force at point C. Let this equation is equation number 2. Now we have this beam, so if we draw this beam and if you cut the beam over here, and let's assume I draw the beam like this. So this is RA, reaction force at point A. This is the, if you cut the beam at this AA section, for example AA section, so this is AA section, if you cut the beam, so there will be a shear force and a couple is a moment will be there. So this force is V and this moment will be M. Clear? And this distance, let this distance is X. Now this X is greater than 0 and it will be less than A. Means it start from here and it can go till this point A, but it is less than A. So in this duration from x is 0 till x is A, we are going to find the shear force. So you can see that there is a vertical force. Sum of all the forces along y direction must be equal to 0, and the upper direction is positive. So there is RA force that is acting upward, minus there is shear force that is acting downward. So if you put the value, so RA will be equal to V shear force, and this V is RA, as RA is from here, you can see this RA is equal to PB over L. So this is the shear force that will act. This is the magnitude of shear force that will act from x is greater than 0 and less than A. Now we will find the moment equation. Let this point is J point, for example. So moment about J is equal to 0. So you can see there is a moment M is also applied due to cutting, shearing of this beam. So this will be taken as positive, and one force, that is RA into perpendicular distance x. So that will create a clockwise rotation, so that will be minus RA into x is equal to 0. So if you solve this, so this M will be equal to RA into x, and this RA is equal to PB over L and into x. So the moment equations will become equal to PB x over L. Now this is the moment equation, and it is valid for when x is greater than 0 and x is less than A. So these are the two equations. Let's say this is equation A and this is equation B, and we will use this equation A and B for drawing the bending moment and shear force diagram when x is equal to 0 and x is less than A. Now we will move toward this section. For example, if I solve it over here, let's solve it over here for simplicity. So if I draw the beam again, so this is, let's say this is total length, this is the beam at this BB section. For example, this is BB section, or you can say B dash because B is also given over here. So do not confuse. So there will be this will be RA, this was RA, this is point B where P is applying, and this distance from this point to this point, this distance is A, and from this point till the beam is cutted, this distance is, for example, X. So definitely this is that BB dash section. So here you will have a shear force and followed by a couple due to reaction. Clear? So if this is total is X and this is A, so definitely from this point till this point, this distance will be equal to X minus A. Clear? So now we will find the shear force equation for this beam or this scenario. So sum of all the force along y direction must be equal to 0 and taking positive in upward direction. So now you can see there are three forces, RA, P and this V, and that is acting. So RA is positive, minus P is negative because it is acting downward, and V is also negative. Clear? So RA is equal to PB over L minus P minus V is equal to 0. Now this V will become equal to PB over L minus P, and if you take P is as common, that will be equal to B minus L minus 1. This will become shear force equation. Again this V is equal to P into, this will be LCM L, this will be B minus L. Clear? Now if you know that this is A and this is B, or if you can see over here that if you see, look at here, you can see that L is equal to A plus B. Clear? Then B is equal to L minus A. So if I write B as L minus A minus L over L, that will be equal to minus PA. This L will be cut with this, so that will be equal to minus PA over L. So this is the equation of shear force. Shear force equation. I do not have sufficient space, so I have to again move to downward. So we have equation P is equal to minus V is equal to minus PA over L, and this shear force equation is only valid for X is greater than A and less than B. Sorry, less than L. Clear? Now we will find the bending moment equation. So bending moment equation, M at point, let's say this is point, any point, for example, if I will move back upward again to this equation, if this is point O, so moment about point O will be equal to 0. I will write it just for understanding purpose. So moment at point O is equal to 0, taking the counterclockwise as positive. So there is a RA force into perpendicular distance X, and this will create a clockwise direction. So that will be negative minus P into X minus X, and this is creating positive, so it will be positive distance. Plus there is a moment, reaction moment, that is given, so this equation. So I will write this equation downward so that we can proceed further, and this equation is valid for when X is greater than A and less than L. Means it starts from X is greater than X is greater than 0 and less than L. Again also correct it, X is greater than 0 and less than L. Clear? So I will write the above equation, moment about point A, that we calculated earlier in above equation, that is written as minus RA into X plus P into X minus A plus M is equal to 0. Moment about this is equal to 0. So minus RA is equal to P B over L into X plus P into X minus A plus M is equal to 0. Now further, if you solve this, so this M will be equal to PB X over L minus P into X minus A. Clear? So again, if you take if you multiply it like PB X over L minus P into X minus P into A. Clear? Now PA into, just a minute, let me confirm one thing, minus PBL over X, PBM in plus 0, and this PA into L minus X. Okay, clear. So if again I delete some portion and write it again, okay, if you leave this M over here, if you leave this M over here and you can bring it out to this. So this will be PBL over x minus P into x minus A. Clear? So again you have to put the value of this B as x minus PB into PA into x minus PA. Wait a minute. This m is equal to P minus x. Clear? So this PA minus PX PL minus A. Okay, this B is actually L, as we know that L is equal to A plus B, so this B will be equal to L minus A. So I will replace the value of this B with L minus A, so that will be equal to P into L minus A into X over L minus Px plus Pa. Clear? So if you again further simplify it, so this m will be equal to PL into x divided by L minus P minus PAX over L minus PX plus PA. Clear? So this L will be cancelled with this, so it will become equal to PX minus PAX over L minus Px plus Pa. So this will cancel with this, so this moment will become equal to minus Pax over L minus plus Pa. Again, if you are going to take Pa as common, so Pa will become equal to 1 minus A over L. If you take common Pa here, it will be 1, and Pa it will be equal to x over L. Sorry, x over L. Clear? So that is the equation of moment Pa into 1 minus x over L, and it is valid for, it is the shear bending moment diagram which represent x is greater than 0 and less than L. Clear? So now let's draw the shear force and bending moment diagram. So for example, this is the beam and the loading was shown over here. This is at point, this is at point P, for example. This distance was A and this distance was B. Clear? This is the reaction force RA which we have calculated, and this is the reaction force RC. So if you are going to draw the shear force diagram and bending, for example, this is the vertical line, this is the vertical line over here, and this is the, for example, horizontal line. So first I will draw the shear force diagram. So if you remember, you have wait a minute. So if you remember equation A and B, so this was the equation for shear force for when x is greater than 0 and less than n, that is PB over L. It means this is some positive value from this point. Let me draw it using, so this is a positive value, and let's say take it at this point. So from this point, and this is the, and this point, this distance is actually A. So the shear force from this point will be a horizontal line till point this. Why? Because at x is equal to 0 and at x is less than a, this shear force will be PB over L. This is again PB over L. Now if you want to draw further shear force diagram, so you will use this equation, minus PA over L. So what does it mean, minus PA over L? So at this point, this will, from this point it will go toward downward. So how much it will go downward? It will go to PA over L, sorry, PA over L. And from the equation you can see that from x is greater than 0 or greater than a, sorry, it was greater than a and less than L, it will be constant. So this will be your shear force diagram for the above beam. Again, let me correct it. It is greater than A but less than L. And similarly, greater than A and less than L. Now we will move toward the bending moment diagram. So from equation B, bending moment diagram, equation PB into x over L. I will write over here M is equal to PB over x over L. That was from x is greater than 0 and less than a, and this was the after this. So if x is equal to 0, if this is the, for example, this is the baseline, for example, if x is equal to 0, so this moment will be 0. Clear? Now you can see that this bending moment, shear force at this point is 0. See, clear? So your shear stress will be maximum over here, and it will be a straight line. If I draw it roughly, you will be experienced when you solve a few more problems. Clear? So you can quickly judge, will it be a straight line or curved one. So it will be a straight line. Clear? And then at this point this is 0, and then its shear force is negative, so the bending moment will also come toward this point, because this equation is valid from x is greater than a and less than L. So if you put this as L, so this will become 1, and 1 minus 1 is equal to 0, so 0. So at this point bending moment will be also 0, and you have, as this is a straight line, a flat line of 0 degree, so you can easily join them and it will be a straight line. So this will be your bending moment diagram. So now the question is that at this point the bending moment will be maximum. So how you can find the bending moment maximum? So you have this equation, that is this one. Clear? So if at x is equal to a, so if you put x is equal to a, so moment will be equal to PB A over L, and that will be maximum bending moment. Clear? I hope you have enjoyed the problem. I am again repeating that you will learn it when you move further to the higher problems, and you will definitely your queries will be cleared further. These problems are very interesting problems, and you can easily learn them if you solve or practice a few problems. In next few problems we will move toward the numerical values, and then you will be able to draw the shear force and bending moment diagrams with the help of values. Till now, up till now we have done these problems that was just a general problems with no constant values. There are a and b values. These are the values that we have given. So in next few problems we will solve them by using numerical values, and that will further clear your ideas. Thank you for watching the video.